All right, let us take the limit of x squared minus 36 all over x plus 6 as x tends to negative 6. The first move that you'd want to do most time when you're taking limits is just to evaluate. So you would put negative 6 here. But if we put negative 6 here, negative 6 plus 6 is going to give us a 0. And a 0 at our denominator is not good. So we can't do that. So we want to see if we could find other options. One of the things that we could do, though, is that we're seeing the difference of 2 squared on top. So let's look at the numerator. Let us factorize the difference of 2 squared. We're going to get x minus 6 and then x plus 6. Then definitely this is all over 6. Definitely we see where we could cancel 6, x plus 6, we could cancel x plus 6, we could cancel x plus 6 with x plus 6. So what we're really left with here is the limit of x minus 6 as x tends to negative 6. So at this time, we can now evaluate. Let's substitute negative 6 here. So it's going to be negative 6 minus 6. And the answer is negative 12. Let us take the limit of x squared plus 15x plus 50 all over x plus 10 as x tends towards negative 10. If we're supposed to substitute the negative 10 here, we're going to have a 0 on our denominator, which would have made everything undefined. So we can't take that route. But if we look at the numerator, we could factorize this. What we could do is that we'll factorize this. So we'll have x plus 10, x plus 5. That would have factorized the numerator. And this is all over x plus 10. We can cancel x plus 10. So what we're really left with is so here it is that we could substitute our negative 10. So this is really negative 10 plus 5. And this is equal to negative 5. So the limit is actually negative 5. In this video, what we want to take is the limit of 1 over x plus 1 minus 1 all over x. So the first thing that we'd want to do is to evaluate at x equal 0, which means we would want to substitute 0 here. But if we do that, you'll definitely see that everything will be undefined because we can't have a 0 at our denominator. So what it means then, we have to try to break this down some more to see if we could cancel some stuff. So let us focus on the numerator. So let's pull it apart. So on the numerator, what we have is 1 over x plus 1 minus 1 over 1. So I'm going to represent it as 1 over 1. And then I'm going to create one single fraction from this. So I'm going to employ a quick cross multiplication. So here, I'm going to use this times this times that over that. So 1 times 1 will give me 1. 1 plus x plus 1 times 1 will give me minus x plus 1 there. All of this is going to be over x plus 1 times 1, so it's just x plus 1. If I simplify my numerator still, I'll have 1. Then if I distribute this negative inside, I'm going to have negative x and negative 1 all over x plus 1. If I keep simplifying on top, what I'm going to have is 1 minus 1. So I'm just going to be left with negative x because this positive and negative 1 will actually become 0. And this is on top of x plus 1. So this on top here is actually this. So let us rewrite this. But this time, I'm going to represent my numerator. But instead of using this, I'm going to use this as a regular division here. And then dividing by x, which means x over 1. Remember that whenever we divide, we normally change our division to multiplication. So I wrote back my first fraction. I'm going to change my division to multiplication. Then I reciprocate. So I'll have 1 over x. At this time, we're noticing, though, that we're able to cancel. So x cancel into itself 1 and x here 1. So on top, I'm having negative 1 times 1 which is going to be -1, which is on top. And on the bottom, I'll have x plus 1. At this time, I really can see what I have because remember, this is actually the limit as x goes to 0. At this time, I'm able to substitute my 0 where x is. So I'll have 0 plus 1. So finally, what I do have is -1 over 1. And this is actually -1. So generally speaking, the limit of 1 over x plus 1 minus 1 all over x as x tends to 0, the limit of that is -1. So there you go.